Hi everyone, I'm Binyang. I'm a postdoc in the Department of Mechanical Engineering at MIT. I'm working on human AI hybrid teaming for engineering design, and my research covers the development of AI agents and the dynamics within human AI hybrid teams. Today, I'm honored to moderate this session and discuss the 5 inspiring presentations together with you all. Now, let me introduce our presenters briefly. Our first presenter is Josh Gyory. He is a postdoc researcher in mechanical engineering at Carnegie Mellon University in the US. Our second presenter is Margherita Tufarelli. She is a PhD in design and researcher at the University of Florence Studies, Department of Architecture, Design Campus section. Her research interests cover the interaction between culture and digital technologies through the lenses of design culture. Dr. Apurva Rajesh Patel is the third presenter. He obtained a PhD degree from Clemson University in 2021 and is now a postdoctoral researcher at the University of Texas at Dallas in the US. Our fourth presenter, Flore Vallet, is a researcher on human-centered design at ART System and an assistant professor at the Central Super before she was an assistant professor at the Mechanical Systems Engineering Department of the University of Technology of Company. Her fields of interest are practices of eco-design and eco-innovation in industry, and for education and human-centered approaches in design and eco-design. Leah Chung is our last presenter. She is a PhD candidate at Carnegie Mellon University. Her research is focused on human-AI collaboration in engineering design. In the following, we will watch the presentations and then have a discussion on the roles of AI in design teams. I encourage our audience to write down your questions for each presenter and comments for this topic in the session chat during the presentations and discussion. Now let's start the presentations. Thank you.
Hello, my name is Josh Gyory. I'm a postdoctoral researcher at Carnegie Mellon University in the United States, and I'm excited to present my work entitled, Is it Human or Is it Artificial Intelligence? The Perceptions of the Impact and Effectiveness of Process Managers Based on the Manager's Identity. So the motivation for this research really stems from the emergence of artificial intelligence as a means to augment human capabilities. So it's been shown that incorporating AI agents into human teams can not only increase their team performance, but can fundamentally change the problem-solving behaviors of the team. So trust between human and these AI agents is a critical factor to consider, particularly as AI agents become more highly integrated within a team. While trust won't be specifically defined or isn't measured in our research here, it is definitely of importance when considering extensions of this work. So our large-scale study from which this data originates from originally just compared the performance and behaviors of teams that are guided by either an AI or a human process manager. So the process managers were able to intervene at discrete points in time with a set of prescribed interventions. This was examined in the context of a highly complex drone design and path planning problem using a collaborative platform developed by a research team called HiForm. I don't have time to go into immense detail on HiForm or the exact design of the experiment or the underlying computation of the AI agent itself, but I highly encourage you to read some of our related work, one of which is shown right here. So within a team, there are three main roles: drone designers who design the drones, path planners who design different path plans, and a business manager that manages the team. And these roles work together to maximize their profit of their team by delivering packages to a customer market. So throughout the entirety of this experiment, team members did not know whether it was the AI agent or the human process manager that actually guided their teams and provided these interventions. So here's the prescribed set of interventions that the human and the AI process managers could provide to their teams. 6 of these related to actions that could be taken by different team members, while the other 6 of these related to communication behaviors amongst the team. And what's important is to show that these were standardized across both types of managers, and this was done to reduce extra variability within the experimental design. The right-hand column of this chart also shows that different team roles received the different interventions. So remember, there's the 3 team roles: the drone designers, the path planners, and the business. So while our prior analysis of this data compared the performance and team behaviors between the human versus the AI managed teams, our goal here is a bit different. It's to look at how the perception of the manager's identity impacted how the team members perceive the managers themselves. So we did this through post-study questionnaires, which we conducted with all of our team members as well as the process managers to gather some information on some of these broader themes. So what the team members thought of the performance of their team, what they thought of the effectiveness of the process manager and the interventions, and what additional types of interventions they would have liked to give / be provided with. And just for the team members, we asked them, so this was the last question on the survey, what they believed to be the identity of the process manager, whether it was a human or an AI agent. So it is with this final question on the survey that we regrouped the teams to reanalyze the data and study our major research goal. So we found that regardless of the true team condition from the prior experiment, that 75% of all team members still believed the process manager to be an AI agent rather than a human. And this was regardless of the actual condition which they were placed in. And some of the major themes that emerged from this rationale include things such as the repetitive nature and automaticity of the interventions, the process manager seeming too passive, aggressive, and formal, and the ability not to be able to directly chat back or gain direct feedback from the process manager. So now regrouping the team participants based on their perception of the manager's identity, we found first that the team members were actually more likely to adhere to the interventions if they believe the process manager to be a human. So this chart shows on a categorical scale from always to never, the percentage of team members that fall into each of these categories. So for example, nearly 40% of the team members said they always follow the interventions when they believe the manager to be a human, compared to only 20% when they thought it was an AI agent. So this shows some bias towards the human process managers. Looking at how they perceive their team's performance, we found no difference here. So these charts show how teams rated the performance and cohesion on a sliding scale from 0 to 100. So teams perceive their performance similarly based on their belief of the process manager. However, it gets pretty interesting when we start looking at how they perceive characteristics of the interventions and the process managers themselves. So these charts show on a similar scale how the teams rate the relevancy and helpfulness of the interventions, as well as the sensitivity of the process manager to the needs of the team. Overall, we found that members perceive interventions and managers as significantly more effective when believing the process manager to be a human. So again, this is indicating this bias towards these human process managers. And it's interesting because this is actually in conflict with findings from our other work, that I hinted at earlier, which actually showed that marginal increase in performance from the AI managed teams. So while the AI managed teams perform better, the team members perceive them as significantly less effective. Finally, in order to improve our AI process manager framework for further refinement, we asked the human process managers what triggers they used in their teams to intervene when they did, and what types of interventions they would have liked to provide but could not. These are some of the major themes that emerged across both of these questions. including ineffective and ineffective communication as a significant trigger to intervene, and being able to provide more customized interventions for individual role and boost team morale. We believe that our AI process manager framework can be improved with future iterations and and included in further studies to study human AI management. So overall, this work shows that teams' perceptions of the identity of the process manager significantly affects their perceptions on their influence, with significant research efforts focusing on integrating AI agents within human teams. Understanding the perception of their human counterparts is critical to build better hybrid teams. Thank you to our research sponsors for supporting this work, and thank you for listening to my presentation. I look forward to discussion at the end of the session. Thank you.
With digital transformation, technologies have a transversal impact on the way of doing things and living places, proposing new subject-object relationships of radically different complexity. Rapid technological advances return new supporting tools in the design production realm, changing the way we innovate and deliver value. Design is challenged by a profoundly transformed design process, operating in an increasingly fluid environment with blurred boundaries between physical, digital, and biological sphere. The aim of this presentation is to address this intense path that is returning profound technical, scientific, and economic productive change that digital tools can conduct. Changes involve the input in design management and control and the output with product performance and meaning. The generative design process is an iterative design process done by a designer and algorithms. The iterative process is precisely in the fact that the flow just described in this slide can be repeated until a product that meets the requirement is reached. The final product will be the result of a collaboration between the designer and the algorithm, capable of optimizing the relationship between form, function, and material. Generative design advantages are numerous in terms of time saving and optimized design and industrial processes. Advantages are in countless solutions to be analyzed in performance control and in time and cost optimizations. The potential of generative design environment still increase gathering the progress made in the production processes like additive manufacturing and new materials, which allow the production of models with complex or organic geometries that would have been difficult, if not impossible, to achieve with traditional product technologies. And like John Gyory said, it seems that computer-aided human designers will produce better designs. In this framework, computational design and generative algorithm get an amalgam of human intelligence and machine intelligence. The result is something infinitely more prominent than pure sum of parts. Then computational technology intervene in thoughts, approaches, and idea generation, determining the new ways of defining things and their relations, giving structural transformation for the design discipline. Computational design then intervenes in the product system, overwhelming the characteristic and structure of everyday products, but also on the methods and tools to make them, like on the entire design process, raising critical questions about the ways design designs. With generative design software, the design processes take on new path, opening an overturing of the established design paradigm that evolves according to the necessary ability to know how to manage a large amount of specific information right from the preliminary stage of the project, actually changing the way products are designed. Design intelligence then merges with artificial intelligence, giving life to an intelligent design that required an evolution of the knowledge and skill traditionally required, not so much according to the role of artificial intelligence in the generative process, but concerning the role of the designer in the new process that configure. We have reached a condition in which we design process-to-process designs. The traditional design process is divided into a phase of analysis and quantitative and qualitative data collection called the divergent phase, followed by a synthesis process in which possible solutions are identified and where the design agency resides. The process is repeated with subsequent phases until designers get to the preferred solution. In this last phase of definition, that the design process connects more coherently with production. Today, the issue is infinitely more complex and disruptive, since the connective and combinatorial change of generative design tools make artificial intelligence participating directly in the design process. Designing with generative design requires focusing on processes that links elements of the project and keeping them present in the design from the outset. The designers dealing with these new tools but identify best solution among the many solutions proposed by the software based on different parameters. This allows the evolution of morphologies understood and interpreted as a system of relation between the parts in which the algorithm operates and simulates the new solution in real time, returning a profoundly changed approach to the project. Generative systems offer then a real paradigm shift in the design practice, in the design process, and in the material expression of the process. This change affects the interpretation that designer can give to artifacts and the action that manipulate them, effectively shifting attention from singular object and individual component to an holistic vision that interprets artifact as a system and process composed of interactive parts. Indeed, such a holistic approach can represent the basis for a change in product design process and approach in general. Moreover, generative design processes have the potential to bring a wider cultural effect on design practices by bringing new methodologies, but also new philosophies. The algorithm of generative design creates, in a very short time, thousands of possible solutions for a product based on criteria and objectives established by the designers, who only has to make a choice. However, where the morphological development occurs through an algorithm that provides a series of variants based on given inputs, then it's the design DNA that changes radically. In conclusion, generative design, the focus shifts from the results to the process, bringing the designer attention to process control. The model is no longer the goal of the project, but is the terrain for an experimentation, study, and verification. There is therefore a strong synergy between the designer and the artificial intelligence algorithm of generative design, which, through a different but still iterative process, together reach the best possible design solution among all those generated. In this sense, the challenge posed to contemporary designers falls on critical understanding of the tools available, on their careful declination and implementation, guiding and controlling the different phases of product development for the creativity to realization. With the increasing complexity, designers need then to orientate themselves, questioning the impacts of data revolution of practical tools and processes on the extension and contraction of the design space in this new context and challenge that we derive from them.
Good day, everyone. Today I'm going to be talking about some work we have done comparing students and machine predictions when it comes to predicting market price from function structure models. This is work done by myself and Dr. Joshua Summers. We're both at the Mechanical Engineering Department in the University of Texas at Dallas. So to start out with, I want to look at a little bit of background for modeling human behavior and design. People have used preference modeling to model human preferences in design, looking at stakeholder preferences or consumer perception. Utility functions and multi-objective optimizations have also been used as a more data-driven approach. Subjective behavior preferences in design have been modeled using fuzzy sets or vector-based approaches for aesthetics for automotive industry, and there's been some work using artificial neural networks for modeling human perceptions of sound quality, specifically looking at human behavior in design. Chris McComan and his colleagues have used Markov chains to model how humans behave in a trust design activity. They've also used deep learning agents and simulated teams to model human behavior. So what we want to do here specifically is actually look at these two research questions: how artificial neural networks compare to students in predicting market price, and how the type of information provided to the predictor, which may be machine or student here, affect the accuracy and prediction of the accuracy and precision of the prediction. So we're looking at two main variables here. We're looking at the type of predictor being used, and we're also looking at the type of information being used, right? So there, the predictors are students and ANNs, and the type of information may be just the topological information, or topological and vocabulary-based information. And the variables we're trying to predict here or measure are accuracy and precision of the predictions. We are predicting market price using function structure models. These are models of household electromechanical products ranging from 15 to 30 functions and 20 to 40 flows. And the price of these products ranges from $3, as cheap as $3, to up to $215 roughly. And we've used a k-fold cross-validation for both student and machine predictions to kind of to avoid the training bias in the accuracy. So how did we calculate predictions for both cases here? For the machine predictions, we took the function structure models and we converted them into a bipartite graph and entity relation graph, essentially. And then we used the graph to calculate 29 graph complexity metrics. There's been some work done on that, which you can read on. And from there, we used the complexity metrics as inputs to a set of neural network architectures, along with the known market value or market price. And that generated a set of predictions, which we will then use the average prediction or average value of those predictions. For the perspective of students, we tried to replicate a similar approach there. So we gave students 12 function structure models to review. So this is trying to replicate the training aspect, along with the associated market values for those function models. And then after a review period, we gave them 3 new products where they were asked to predict the market price. For students, we asked them to predict a minimum, maximum, and an average market price. And we also asked students to tell us how confident they were about those predictions. And finally, there was an exit survey where students told us about their knowledge and level of comfort with function modeling and overall confidence in predictions, and also try to articulate the prediction process they use. So a brief look at results here. We found that students and machine predictions were similar in terms of prediction accuracy. Student predictions were better for 8 out of 15 products when using topology only, and when using topology and vocabulary data, machine predictions were better for 8 out of 15 products. So more or less the same there. Interestingly, we found that some products favored one predictor over the other. So the juice extractor and sander were better predicted by ANN in each case, versus the hairdryer and nail gun were better predicted by student predictions in each case. Student predictions also showed smaller variances as expected, because we only had about 15 students per product compared to the 18,900 predictions on the machine prediction side. And students also generated no negative predictions. And finally, the predictions with topology only showed smaller variances, so adding the vocabulary information there resulted in a larger variance on predictions per part or per. So to wrap up here, some conclusions and some future work. So overall, we found student predictions are comparable to machine predictions. We also found that predictions without vocabulary were more precise. I want to talk about some limitations for this study. So we had a small data set for ANN training, 15 products, which is usually not large enough for generating good predictions. We also used a mix of shallow and deep networks here, which may be contributing to the variance in predictions. The students were also not necessarily very familiar with function structures. They had been introduced to function structures, but the amount of comfort and expertise there may not be very high. And finally, the student confidence in predictions was unclear. They generally reported a moderate level of confidence. And where to go from here? So a few low-hanging fruit. We can look at how the confidence in predictions affects the accuracy and precision. We can also look at how the size and interconnection of the function model affects the prediction accuracy and precision. And finally, we can take a look at whether experience with function modeling affects the human predictions. So thank you for your time, and your questions are welcome.
Hello, my name is Flore from Research Institute SystemX and Central Supélec, and I'm very happy to present you this work conducted in the Anthropologist chair entitled Matching Synthetic Populations with Personas with a test application in the case of urban mobility. So our initial questions is to elaborate or to investigate the synergies between synthetic populations and persona-based approaches. So here an example of personas we developed for a workshop on robo-mobility. So what are personas and synthetic populations? Personas, as a reminder, are fictional user models which are very commonly used in user experience design for communication, but also to design new products and services. And they can sometimes be criticized for their lack of solid empirical ground. Personas are usually generated in a creative way based on interviews and observations, but more recently with more quantitative approaches based on big data, as exemplified with the persona generator on the right. Now, what is a synthetic population? It is a statistical representation of, for instance, 10% of a real population, and here each agent or person is modeled, and it is a basis for building multi-agent simulation in the transport field. So we notice, of course, some commonalities between personas and synthetic populations, and we seek to connect the two. So the proposition of the paper is to be able to generate personas, not only qualitatively, but also in correlation with the agent of the synthetic population, and conversely, to be able to inform the population generation by qualitative data of personas. So here is the proposition. You've got the synthetic population on the left-hand side based on census data, transport surveys, company-related data, and spatial data, which we are going to cluster into classes, and this is going to enable the development of more statistically informed personas, and we can find several of them on the right-hand side, also informed by some qualitative inputs. So we've got a case study for studying the urban mobility in Paris based on a synthetic population generated by one of the co-authors for Paris. And 8 classes were generated thanks to a Gaussian mixture model. And the classes were attached to the 20 districts of Paris. So for the 8 clusters, example of cluster 5, which is a cluster of senior people, average age around 70, and retired for socio-professional category. So here's the cluster distribution per districts. So obviously, the clusters are not equally distributed in the Paris area, as you can see here on this graph. So what did we do? We took some qualitative personas which were already generated for a study, an existing study for Paris. And then we try to match them to the clusters, testing their age and position, adjusting their living area regarding the existing data from the synthetic population, and finally matching the personas to the clusters. And here is the final outcome, a set of personas which are now attached to a probable living area in Paris. So, of course, the couples, for example, Leila and Julian, belong to different clusters, but they are going to be settled in the same district. And here, cluster 4, there are no representative because they are young children which are not in the persona set. What can we do next? We can also integrate activity chains which are provided with the synthetic population, meaning that for cluster 1, here we've got the distribution of all the activities that are possible, and the most frequent one is home, work, home at the very bottom, home or home education, home. So, which means what can we do here? We can have personas supplemented now with their activities. And for these sets of personas, then we can attach them to a certain activity, and the 5 activity chains here can account for about 45% of the population. And we can connect, for instance, Camille, who is a student, to the home education, home activity, and Leila, who is a worker, to home, work, home. So conclusion now, we proposed an approach to generate personas based on synthetic populations, and also to enable, in the meantime, a collaboration between UX designers and data scientists. This was exemplified for Paris area. And now we envisage the creation of future personas, but of course, being aware that we need to avoid a temporal mismatch between the current aggregated data and the future projections we could make. Here are the references, and thank you very much for your attention.
Hello everyone, my name is Leah Chong, and today I'll be presenting my paper called Are Confident Designers Good Teammates to Artificial Intelligence? A Study of Self-Confidence, Competence, and Collaborative Performance. My collaborators are Professor Jonathan Cagan and Kenneth Kotovsky. AI assistance has been prevalent in engineering design to overcome the limitations of human design processes and improve the outcome of the process. Some of the benefits include the insights they bring from large amounts of data, as well as different perspectives, and it may even reduce the cognitive biases that humans bring into the process. Together, they can solve design problems neither human nor AI can solve alone. And here are some examples of how AI is assisting human designers in engineering design. The first example is an AI that is providing a best design method to use given a design problem. The second example is a trust design task where the AI is providing the next design move to make. And the final example is the drone design problem where the participants can choose to use a AI-suggested design of the drone to go forward with. And humans are remaining crucial as the final decision makers of the process. They receive a suggestion from an AI agent, then either accepts that suggestion or rejects it and overrides it with their own move. And self-confidence has shown to impact this decision as well as the teamwork of the designers. Prior literature has shown that individuals' beliefs about their own task skills impact various aspects of teamwork, such as effort provision and team production. Not only this, there is a strong relationship between human self-confidence and their trust in use of AI. Another literature has shown that people tend to overestimate their abilities, therefore they're overly confident in their design ability. Some of the costs of this include their distrust in AI teammates, as well as the risky decision-making behaviors in team settings. Some benefits include that the overly confident designers tend to have higher motivation, as well as show less free-riding behaviors during the teamwork. And with that, our work motivation is to see the relationship between designers' self-confidence and their overall competence, first of all, to see whether they are overly confident or not during the design process, as well as overall reliance on AI and overall team performance, which represents their collaborative performance and how it relates to self-confidence. We adapted some data from Chong et al.'s work, and here in Chong et al.'s work, it looks at trust design task in the experimental setting. This task is where, given a trust design task, the participants are asked to make the best action that leads to a trust with a high strength-weight ratio. There were a total of 30 problems in this study. There were 100 participants who are all undergraduate and graduate students and have taken a mechanics course prior to this study. There were two conditions in this study. The first, where the AI is initially high-performing of about 80% accuracy and changes to a low-performing AI of about 20% accuracy after 20 problems. And the second condition changes the order from low to high-performing AI. And taking some data, especially the first 20 problems of the experiment for this study. First, we take the self-confidence data, which is the self-reported data in 5-point Likert scale for the 30 problems. So we can take not only the initial self-confidence of the designers, but also the average of per 5 problem intervals. Another data that we took was the overall competence data, which is the sum of the scores of unassisted actions, which are actions taken before AI suggestions are provided. The third is the overall reliance on AI, which is the average of behavioral data on whether the participants accepted or rejected the AI suggestions. And finally, the overall team performance data is the sum of the scores of assisted actions, which is taken after the AI suggestions are given. And we first looked at the self-confidence and competence and their relationship. Looking at the table below, we see that competence tends to be lower than self-confidence throughout the collaboration process, meaning that they're overly confident, as prior literature has shown. And going back to the plot at the top, we see differences in the two conditions with high-performing AI and low-performing AI. With the high-performing AI, we see that designers are more confident. The more confident the designers are, the more competent they are overall. However, in the low-performing AI, we don't see this correlation. And going into looking at the relationship between self-confidence and collaborative performance, we again see the difference between the two conditions, especially focusing on overall reliance, which is the left plot, and the overall team performance on the right plot. With a high-performing AI, designer self-confidence is not correlated with overall reliance on AI and team performance. However, in the low-performing AI, there are significant correlations. For example, when they're less confident designers, they're more reliant on the AI, and they have lower overall team score. And going into looking at the relationship between competence and collaborative performance, we again see differences in the two conditions. In the first condition, with a high-performing AI, there are no significant correlations, just as with self-confidence. However, with the low-performing AI, we see that competence is not correlated with overall reliance on AI, but is positively correlated with overall team performance. To summarize the results, we go back to the initial question from the title of the paper: are confident designers good teammates to artificial intelligence? And the answer is it depends on AI accuracy. In the high-performing AI condition, we observe a strong positive correlation between self-confidence and competence. And we see that both of these variables are not correlated with their overall reliance on AI or team performance. This may be because the high-performing AI is providing very attractive suggestions to the designers, meaning that they will focus less on their own ability in their decision-making process, but instead they will focus on the AI's ability. The second condition, low-performing AI conditions, showed no correlation between self-confidence and competence, and showed a trend where the designers are relying on the AI only when they're not confident or not competent in themselves. Therefore, in this condition, what we see is that when we can determine whether these designers will be good teammates to the AI by looking at their self-confidence values. Therefore, we see that in the high-performing AI condition, we cannot tell whether they will be good teammates by their self-confidence, but in the low-performing AI condition, we can. And with that, I would like to conclude my presentation and open the floor for questions. Thank you.
Yeah, thank our presenters for the great presentations. Now, yeah, please feel free to ask your questions in the session chat, or you can also request to unmute yourself to join the discussion on live. I can start with my question. Yeah, for Josh, how do AI and humans decide what interventions to send respectively? And based on your knowledge, how do their processes differ?
Could you repeat the first part of that question? How does the AI choose?
Yeah, how do they decide which intervention to send?
Okay. Yeah, so I didn't have time to go through this in this talk because it's sort of beyond the scope of what I was able to include in the paper. But so the AI that we created is a process manager of the design teams. So what it does is it tracks in real time the communication and the actions that team members are doing within their teams. And we actually trained our AI on prior team problem-solving data within the same platform. So we used Highform, which is a collaborative design platform that our research team created. It simulates a drone design and path planning problem. So our AI was actually trained on prior high-performing data using that same platform. And what the AI does in selecting interventions is it tracks the characteristics and behaviors of those high-performing teams, their action and communications, and tries to emulate that within the teams that they're seeing in real time. So in that respect, the AI is trying to push them to how the high-performing team performed prior. So that's the AI, and we directly compared that with humans in the same role, and the humans took more of this observational approach. So they were just tracking the teams in real time and choosing the types of interventions. So that was sort of the goal of our prior paper, was comparing this data-driven AI approach to process management and comparing it to what humans would do in the same role. So that's how they chose the different types of interventions.
Yeah, thank you for that. Yeah, it's quite clear now. Yeah. Great. And the second question for Prof. Summers, could you explain what the topology and the vocabulary convey as input?
Okay, so you're asking about what information is actually in the topology versus the vocabulary. Okay.
Yeah.
So what we looked at from a topology only point of view is a graph of nodes and arcs for function structures that had no information on the actual name of the function or on the flow. So all we had was a blank graph, essentially. And we trained the neural nets on that and gave the same training information to the students. And so essentially the crowdsourcing of students versus our 18,000 neural nets were roughly similar. If we added the information of the name of the functions or the name of the flows, then the students became a little bit better, but not drastically. But that is a crowdsourced students. So we did not find any individual person that outperformed the neural net crowd or the human crowd. So.
Got it. So actually, the vocabulary conveys the information of the nodes in the graph.
Correct.
Yeah, got it. Thank you. And for Professor Vallet, we have, what are the pros and cons of the personas generated from synthetic population compared to the real personas generated using qualitative methods?
Yeah. Okay. Thank you for the question. So the comparison with the personas in the old-fashioned way, let's say, yeah. So basically two, advantages or maybe promises in a way. The promises is to have more statistically informed personas, and that could be really relevant when you're working on some kind of geographical area, territory, where you would like to have some kind of representation of different classes of people and not to forget about some important groups or social groups, right? And also the idea is to have this collaboration, to be able to have personas on the one hand, and also to be able to simulate some services thanks to the synthetic population that is linked to the personas. So it's basically to have the same background in order to work on more interaction parts for services and maybe to have more simulation parts connected together. So that's the promises and the pros and cons that, I would say maybe it's more time consuming, but then the approach is just building up. So we don't know. Maybe it's not. Maybe it's quicker. Maybe it's not. But it depends if the population is already generated or not. Basically.
Yeah. Thank you for sharing the new methods for generating personas. Yeah, and a question for Leah. It's not covered in the presentation, but I'm curious about the overall reliance levels of human team members on the low and high performing AI.
Yeah, so is the question how reliant are they depending on whether they're low performing or high performing?
Yeah, I'm wondering whether the teams with high performing AI, for these teams, the team members rely more on AI.
I see. Yeah. So yes is the simple answer. So if the AI is high performing, then they tend to be more reliant on them, meaning that they use the AI suggestion more. But sometimes it does get a little bit tricky. So for example, for the design problem that I used, which is the trust design problem, it was a sequential trust design problem. And the task itself was very difficult for the participants. And they're not very used to evaluating each move and how good that is in a trust design problem. So sometimes even with high performing AIs, they tend to be very not very reliant too, because they couldn't tell whether the suggestion was good or bad, because they themselves are not very good at evaluating that.
The cognitive loading for interpret the AI results is a little high. And
it was a difficult task for them.
And I noticed there is change in AI performance during the experiment. I'm not sure whether humans' reliance change accordingly with the change in AI performance.
Yeah, so there's actually details in that. It's hard for me to say whether the change just let them to rely more or less. It kind of depended on the individual experience that they were having. But the change actually wasn't really included in this paper. I didn't include the data, including the change as well. I only used the first 20 problems, which is before the change. But the change was included actually for a different paper that's on its way to getting published. And you'll be able to see more detailed results in that paper about how the change affected their reliance.
Yeah, I look forward to that.
Mm-hmm.
Yeah, then I have a question for you all. In your study context, what specific advantages AI has or you expect the AI to have compared to humans? And the second part of the question is, in the future, what can be done to realize the advantages of the AI better in your case?
Could you just repeat the first part? I didn't get it.
Sure. What specific advantages AI has or you expect the AI to have compared to humans in your study case?
I guess I can take
Sure.
the first stab at this.
Go ahead.
So our specific application of AI in my work was specifically managing the design process of teams. And I think one of the advantages of AI in my work is that AI is able to track many different measures and states of teams in real time and over time, which might be hard with, a human manager just observing teams. So for example, in this work, the AI tracked different types of team communication, different types of team actions, and how that changed over time. And I see a great advantage of artificial intelligence in this realm of being able to track all these different measures, especially noisy data, communication, team communication, which I've been studying a lot throughout my research, is quite noisy and hard to deal with sometimes. And I think artificial intelligence is able to mine such noisy data and make some inferences based off of that, where on the human side of things, it might be more difficult. So I think that's the main advantage of AI in my work. And we actually saw increases in performance on the AI managed teams compared to the human managed teams. So there is definitely some marginal improvement in performance that we exhibited with our work.
Great. And do you think AI can be better in your case, and how?
Yes. So actually, this was my presentation from today. So there was we looked at the perceived effectiveness of these different AI versus human in this work, and we found that there was this enormous bias. Even though the AI managed teams did perform better, there was this bias towards the human process managers. And some of the results that we found was that, the AI in our work was fairly automatic sounding, if that makes sense, computerized. So I think having an AI agent that really is imbued in a team needs to be more human-like. And I think in that way, humans will trust and rely on them more if they seem to be more of a partner with the human team. So I think that's one way that we can really further our work within process management of engineering design teams, is how we can have these AI agents that work directly with humans be more human-like.
More interactive, more positive.
Yep.
Great.
I can go next. Guess for me, related to the paper that I presented today, I look mainly at the relationship between humans and the AI teammates. And obviously, there has been so much work on interpersonal teams and how they perform, but not so much in human AI teams. And in terms of the advantage AI has in our teams, is that repeatedly in prior literature and also my work, you observe that humans have higher trust and higher reliance on the AI agents than humans, at least towards the beginning of collaboration. Maybe that trust is lost faster, which we might have to address going forward. But at least in the beginning, they have humans' trust. And maybe in terms of the speed of their teamwork, for interpersonal teams, we might need longer time to build trust towards one another to collaborate well. But with an AI, at least if the AI is high performing, it could be very effective in achieving teamwork in a very quick and fast manner.
Yeah, any improvement you plan to implement for improving the AI?
Yeah, so what was that actually bad AI performance, or let's say moderate AI performance, had pretty detrimental effect on the final performance of the team. So it's better to not have an AI at all than include a poor AI, poor performing AI. So I do think improving AI performance is very, very crucial. Yes.
Yeah, grateful. Yeah, thank you for the sharing. And Prof. Summers, would you like, and Prof. Vallet, would you like to share your?
Yeah. So I will try, and of course I can notice that compared to the other speakers, we are not really exactly have the same kind of relation between IA and humans, because the approach is still really human-centered. But nevertheless, I can see that this kind of approach based on data for personas can help have maybe a larger sample of personas, which could be really interesting. So that could be the plus or the advantage. And I could pass the mic to my co-author, Tjark, who is here with me, and maybe some other things to add.
Yeah, thank you for the question, and thank you for the moderation. Just a quick couple of reflections. I think our situation is a bit different because in our case, the AI was already there, because we are working in a team where we work on mobility and transportation issues from different angles, but we traditionally work rather independent. So on the side of thinking, there are the people who are working on design and simulation. So in our first step, it was really about how to integrate what is there. So it's not the contribution of something new or the integration of AI in the direct design process, but building new links, which was also very important for, let's say, our communication between each other, to understand, to use the same language, to use the same approaches. And I think so far as I can observe it, both parts can contribute and do benefit from it. Mm-hmm. And then there's the second part, which I think is the future work perspective again, which is how are we able to use the design discipline to improve again existing AI-enabled processes. So in that case, agent-based simulation and so on. So again, it's not about using AI to improve the process of design itself, but in that case, it's the other way around, how to use design methodologies which exist, such as personas, such as the ability, for example, to represent changing lifestyles and mobility behaviors, or changing values and mobility behaviors in 2030, to have a better informed, or let's say differently informed synthetic population for agent-based transport simulation, which allows us to represent a broader variety, for example. So it's a bit it's trying to find the benefits on both sides, and I think this is what the question boils down to. What are humans best for, and what are machines best for, and where can we find the best collaboration between the two?
Yeah, it's challenging, but it's promising. Yeah, great. Thank you. And Prof. Summers, would you like to add something? Yeah.
I mean, you ask any faculty member if they want to add something, obviously, of course, we're going to offer up our opinion. I think one of the things that needs to happen with AI is we need to move beyond just the machine learning and more into the understanding. And the type of reasoning that AI is really set up for traditionally is the deductive, inductive reasoning, but not the abductive reasoning. And how can human and agent actually interface to support that? Honestly, I don't think that we have a firm grasp on how two humans collaborate together, let alone a human and an agent. And so if we really wanted to understand what the future should or could hold, I think we need to keep doing deep dives into human reasoning and that collaborative support. I think another thing that I would like to toss out here is, while it's fun for us to always think about how to improve and support things, sometimes we forget trying to understand why and what the fundamental phenomena are that we're trying to study. We are naturally or trained and professionally more engineers, so we like solving problems. But we're also supposed to be scientists, and we're supposed to be asking questions. And sometimes the questions that we ask and the answers we get, it may be that there's no clear path for an improvement, but it is still a new piece of knowledge, a new understanding that collectively might lead to something. So that's just a little soapbox that I figured if you gave it to me, I would take it, to remind everyone it's okay for us to do some research that doesn't have any clear direct benefit if we view that as the scientific discovery.
Yeah, thank you for the in-depth sharing. Yeah, and then I got a question for Leah. The question is, does the previous experience or knowledge of AI influence the initial trust of people into it?
What was the final part? Initial trust of
people into AI.
I see. Yes. So prior experience with AI definitely has an impact. The way that I have included that detail into my work is I collected data prior to the experiment as well, before they interacted with the current AI that they're working with. So I asked them whether they think the AI is good or bad within a 5-point Likert scale. And that data shows what kind of bias they have initially going into the interactions.
Yeah, thank you for the sharing. Yeah, if we don't have any further question for our presenters, then we can close the session now. Thank you for the great presentations and answers to our presenters, and thank you for attending this session to our audience. Enjoy the rest of the conference. See you.
Thank you very much for moderation.
Yeah,
Yes, thank you.
Thank
Thank
you.
you.